The next thing is cycle life. Now here the total storage capacity of a battery that decreases. When we are using it, continuously we are using it, then its total capacity decreases. So cycle life, it defines the number of cycles a battery or cell carries out before capacity reaches 80% of its original capacity. Yes, earlier it was 100 ampere hour, now it is 80 ampere hour. So how many cycles are carried out before it reaches 80 ampere hour of its capacity? It means 80 ampere hour, that is the 80% of its capacity. So that cycles, not cycle, that is the cycle life. So every cycle of charge and discharge is the of the cell that is linked to simultaneous conversion cycle of the active chemicals within the cell. So this is accompanied by gradual degradation of the chemicals in the cell that is not visible to the user. Okay, of course, we won't be able to see it. Okay, the degradation could be a consequence of undesirable and unavoidable chemical reactions within the cell, or an alteration in the morphology of the electrode particles, means the components, they are degrading due to the continuous chemical reactions, charging and discharging. So reactions, they are being carried out continuously. Okay, due to that, the total capacity that is decreasing. Because the cell does not die after the cycle life is over, but its gradual degradation carries on. So that means the capacity that is decreasing. So it works normally, but its capacity decreases considerably as compared when the battery was new. Now another component is self-discharging rate. The name indicates self-discharging. So not discharging through the load, self-discharging means load is not connected. Still, the battery is discharging. So that is known as self-discharging rate. So it is the rate at which a cell discharge while not in use. Because it depends on the temperature components of the cell. So rate of some of the batteries, like the lead acid, that is 4 to 6% per month. Okay, self-discharge rate per month. Alkaline 2 to 3%. Primary lithium metal 10%. Nickel based 10 to 15%, and lithium ion 1 to 2%. Now battery efficiency. The charging voltage for any rechargeable battery is greater than the discharging voltage. Yes, of course, it will be charging voltage that will be greater than discharging voltage. So charging voltage that is equal to the EMF of the battery plus voltage drop because of the internal resistance of the battery. Okay, that should be the charging voltage. Now in case of discharging voltage, the EMF minus voltage drop due to internal resistance. This is the discharging voltage. So EMF plus voltage drop due to resistance, internal resistance, that is the charging, and minus, that is discharging. The discharge energy is always less than the charging energy of the battery due to its internal resistance. So typically a lead acid battery is 80 to 90% efficient in doing the charge transfer. So mathematically we can use this expression ampere hour. Okay, the charge transfer capacity that is equal to discharge energy, the ampere hour, into 100 divided by charging energy. So that gives the efficiency. Now batteries which are used in a PV system, they should be having some desirable characteristics, like first of all it should be rechargeable. Okay, it must allow deep discharge, should have long lifespan, should be easily serviced, should having high capacity and low self discharge rate. Now, some of the commonly used batteries, like a lead acid battery, this is the most commonly used. Okay, so the main components of this battery, they are lead and sulfuric acid. So the name becomes lead acid. So characteristics of lead acid batteries, so they are rechargeable. Their capacity is in the range of 1 to 12,000 ampere hour. So huge range is there. So these are 500 to 800 charge discharge cycles. That is also a good amount. So their life is about 2 to 3 years. Yeah, that's why I said that this one, the batteries, they are having the minimum lifespan as in compared with other components in the PV system. There are panels, they have lifespan of up to 20 to 25 years. Okay, so if maintained properly and used with a suitable charge controller, the operation life can be increased by up to 5 to 7 years. So means it needs proper maintenance. They perform very well for a wide range of temperature, from minus 15 degrees Celsius to 60 degrees Celsius, and can be easily replaced and maintained. So the commonly used lead acid battery is the car battery. So it provides a high current for a very short duration during charging starting of the engine. So they're sometimes used for small photovoltaic system because of their low cost, but their operational life in solar PV application is likely to be short. So the car batteries are not suitable for deep discharge cycle. Okay, that is what is required in a PV system. Another one is flooded tubular plate design. The most common lead acid battery used in PV system is of this flooded tubular plate design. So it is having low antimony plates. Okay, if the DOD, depth of discharge, is maintained, it is limited, then lifespan becomes larger. Okay, otherwise, if the treatment or the condition of maintenance that is not good, then life will correspondingly it will reduce. So flat plate lead acid batteries are often used as a stationary battery for the standby applications. Okay, so although these batteries do not allow deep discharging, so they are not the best choice for PV application because there we need deep cycling. Another category that comes sealed lead acid battery. So sealed lead acid battery is designed mainly to avoid spillage problems. Okay, and the need to top up the electrolyte. Okay, so these are very specific for solar PV system. Okay, so like in the remote regions, where easily or every time we are not able to visit the site. Okay, so there we can prefer for sealed lead acid battery. The sealed lead acid battery are considerably more expensive and less resistant to extreme temperature than the conventional flooded batteries. Now last one, the nickel cadmium battery. So that is a rechargeable battery and has porous plaques of nickel hydroxide as positive plates of the electrode and porous plaque of cadmium hydroxide as the negative plate of the electrode. So that comes the name nickel and cadmium. So that is the positive electrode, that is nickel hydroxide, negative, that is cadmium hydroxide. Two type of nickel cadmium batteries: sintered plate nickel cadmium battery, and second one is pocket plate nickel cadmium battery. The sintered plates that suffer from the memory effect, in which the useful capacity of the battery appears to drop after it has been discharged over many cycles, or if it is discharged at low rates. So these batteries are not attractive for use in PV system. Coming to the next one, the pocket plate nickel cadmium battery. So these can be used in PV system because they have additives in their plates to prolong their operational life and to minimize the memory effect. So they are highly resistant to the temperature condition. Okay, and the capacity, the charge stored, that can be bring down to less than 10% state of charge. Okay, but on the other side, the cost that is high as compared with lead acid battery, because then the cost of the installed system directly affects the cost of energy produced, means per kilowatt per unit energy electricity, that is directly affected by this cost of the individual components. Now a brief comparison between lead acid battery and nickel cadmium battery. So first parameter, cycle time. So lead acid is having 600 to 1500 cycle, whereas nickel cadmium is having much higher, about 1500 to 3500. Next one, efficiency. Okay, so ampere hour extracted to ampere hour restored. It is having 83 to 90%. Nickel cadmium is having 71%. Self-discharge rate 3 to 10% per month for lead acid battery and 6 to 20 per month for nickel cadmium. So self-discharge that is less in case of a lead acid battery. So range of operation, that is minus 15 to 50 degrees Celsius. Whereas in nickel cadmium battery, that is minus 40 to 45 degrees Celsius. Now, investment cost in euro per kilowatt hour, capacity, that is 160 to 200 for lead acid battery and 690 to 1590 for nickel cadmium battery. Now, specific energy cost, okay, that is also in euro per kilowatt hour, that is 0.11 to 0.33 per kilowatt hour. And that is higher in case of a nickel cadmium battery, that is 0.2 to 1.06 per kilowatt hour. Okay, now coming to connection of batteries in a photovoltaic system. Because single battery, the voltage and the current provided or obtained from that a single battery, that is not sufficient to feed the load. In that case, we need a combination. So series parallel and combined series parallel. Very much similar to that of a photovoltaic panel. So series combination of batteries, that is needed when the voltage is to be increased, because in series current will be the same, whereas the voltage will increase. Like 3 6-volt batteries are there, we are connected it in series, then total 18 volt we are getting. Okay, how we connected? Negative terminal of one battery is connected to positive terminal of the another battery. Okay, in this way we carry on. So overall the voltage that is increased. Next is a parallel combination. In parallel connection, but we are increasing the current, because in parallel always the voltage will be same. Okay, so same type of terminals are connected together at a point, like the all positive are connected together of all the 3 4 as a number of batteries we are connecting parallel. Positive terminals of all of them should be connected at one point, and negative terminal of all of them should be connected at another point. Okay, then the capacity, like how much capacity in ampere hour for one battery, for another battery, they all are additive. Okay, so but the voltage that is the same. That is of the single battery. The total voltage will be the same as that obtained from the single battery. Now mixed combination, here we can a combination of series and parallel both. This type of connection is used when both voltage and current both are to be achieved up to a desired level. Okay, like the series one, for the voltage level we have achieved it. Now further make parallel connection when we want to increase the total current. So now maintenance of batteries. So first of all, proper maintenance that is needed so as to increase the life of the battery. So that is why keep the battery clean. First characteristic, you have to keep the battery clean. So if the battery, the top of the battery that is dirty, corrosion will soon be a problem. Electricity will begin to leak from the battery connections through the dirt. But, okay, only use fresh water and a rag to clean the battery. Next, maintenance activity, that is to test each cell with the hydrometer. Okay, so each cell. Because if one or more cells measure very differently from the others, the battery is probably beginning to fail. Next is keep the battery cells full of electrolyte. The battery cell should be checked at least once a month, and special high purity water should be added if the electrolyte or the water level that is low. Okay, if the water has to be added often to one or two cells but not to the rest of the cell, then it is an indication that a battery is failing. We need to replace it. Another activity should be the equalization of battery. Okay, sometimes the battery can be repaired by deliberate overcharging, but we cannot just simply provide an extra charge. Because we need to give a very slow, controlled over voltage. Okay, overcharge means it is charge, but higher charge, overcharge, that should be given very slowly. So we call this term is called as equalizing charge.